Welcome back to Josh Does Math. In this video we have an application of the derivative. Find all the points on the curve y equals 4x cubed plus 6x squared minus 24x plus 10 at which the tangent is horizontal. So we have some curve right here. It's a cubic with a positive leading coefficient, so it's going to look something like this. And we're looking for all the places where we have a horizontal tangent. So at most we can have two horizontal tangents, as you can see from the simple sketch here. If it's a really simple cubic and we have something like this, we're only going to have one horizontal tangent right in the middle right there. So we got one or two horizontal tangents and we're looking for where they are. So here's our function up here. How can we find, or how do we know when this function is even having a horizontal tangent? Well, that would be if the derivative of the function was 0. In other words, if the function has 0 slope at some x value, that's a horizontal tangent. So let's take the derivative of this function here. I'm just going to use the power rule a bunch of times for each term. So for the first term, power out front, 1 smaller on the power, we get 12x squared. Next term, power out front, 1 smaller on the power, 12x. Next term, power out front, 1 smaller on the power, we get negative 24. And last term is a constant, so derivative is 0. So this is dy over dx. So we're looking for where this derivative function is equal to 0. That means we have a 0 slope, and that's a horizontal tangent. So let's just solve this. I'm going to divide by 12 first, so we get x squared plus x minus 2. And then I'm just going to try to factor this if I can. So that's going to be x plus 2. X minus 1 is equal to 0, which means x is equal to negative 2 or x is equal to 1. So at these 2 points, the derivative is 0. So these x values are going to be where we get horizontal tangents. So it says find all the points on the curve at which the tangent is horizontal, so maybe we want an x comma y coordinate for these points, which we can easily find. You just plug them in. If you plug in 1, we're going to get 4 plus 6 minus 24 plus 10. So that's going to be 10 minus 14. So that's going to be y equals negative 4. So one of our points is going to be 1 comma negative 4. And for our other point, I'm just going to plug in the negative 2 value here. So negative 2 to the third is negative 8 times 4 is going to be negative 32. Negative 2 squared is going to be 4 times 6 is going to be 24. Then we're subtracting negative 2 times negative 24. So that's like adding 48. And then we're adding 10 to the end. So if you just simplify this right here, that's going to end up being negative 32 plus 72, just make that an 82, and this is going to end up being 50. So our second point at which we have a horizontal tangent is at negative 2 comma 50. So those, you could say, are the 2 points where we get horizontal tangents, and that's how you do an application of a derivative like this. Thanks for watching.